Your AI agent went live. 10 minutes later, it got stuck in an infinite loop, hallucinated a non existent API parameter, and burned through a $500 in OpenAI API credit. Your instinct? Blame GPT-4. Try another round of prompt engineering. But here is the brutal truth, you are fixing the wrong thing. In production systems, agent failures are almost never model failures. They are the system architecture failures. To build systems that actually work in enterprise environment, we have to stop treating large language models like autonomous magic brains. Instead, we must treat them as probabilistic compute units wrapped inside a strictly deterministic architecture. To eliminate non determinism, we split our system into three distinct layers. First, harness engineering. The operating system. It manages context injection, memory, security, and tool APIs. Second, graph engineering. The routing topology. It controls state transitions, conditional path, and human approvals. Third, loop engineering. The local execution engine. It handles the micro layer, the thought to action to observation cycle. Together, they form a strict hierarchy. Harness provides the infrastructure, graph defines the allowed pathways, and loop executes local tasks. Observation on context drought is killing your agent. As an agent loops, context windows fill with raw tool outputs and stack traces. LLMs suffer from attention degradation and the lost in the middle phenomenon. A engineered harness must perform continuous context compaction, pruning raw outputs and serving only minimal required context per turn. Observation 2, LLMs cannot self grade. Asking an LLMs to check its output creates an echo chamber. If it was blind to bug during generation, it will be blind to it during evaluation. Loop engineering requires external truth engines, compilers, unit tests, and API schemas. Fit the model ground truth errors from real tools, not subjective self assessment. Observation 3, autonomy and predictability are inversely related. Giving an agent total freedom over an end to end task guarantees edge case failures. Graph engineering constrains scope. By breaking complex tasks into small, deterministic state nodes, each LLM call only makes local decisions within a tight domain. Observation 4, unbounded retries burn money. Without hard limits, agent loop infinitely, trying to find unfixable errors. You must enforce deterministic circuit breakers, fixed retry budgets, specific failure context injection, and explicit fallback paths. Let's turn this framework into clean production ready code. We'll build a node that integrates harness compaction, graph state management, and loop circuit breakers. Look at what's happening here. In our harness layer, harness compact context drops thousands of tokens of old execution clutter, serving only the current draft and single most recent error. In our loop layer, we do not ask the LLMs is the code good, we execute it deterministically via standard subprocess execution. The compiler gives us exact grounded truth. In our graph layer, we enforce a hard circuit breaker. If iteration count hits our retry limit, execution stops immediately and route to a human in the loop gate. No infinite loops, no runaway API bills. Next time your AI agent breaks in production, use this triage diagnostic checklist. Is it selecting the wrong tool or hallucinating API argument? That's a harness failure. Fix your JSON schemas and prune your context window. Is it staying off task or executing steps out of order, that's a graph failure. Enforce strict state machine topology and transitions. Is it repeating the same mistake over and over? That's a loop failure. Replace self evaluation with deterministic external tool and strict retry caps. Stop fighting with prompt engineering to fix system level bugs. Treat LLMs as probabilistic engines and build the deterministic architecture they need to succeed. If you found this breakdown valuable, drop a like, check the link in the description for the source code, and subscribe for more deep dive software engineering insights. See you next time.
Hey everyone! If you're enjoying the content, don't forget to like, share, and subscribe to the channel. Your support means the world to me!